All right, here we go. Here is the Unit 6 review from start to finish. Your grandma bought Winter Olympic commemorative coin for $2. Enter the year. Each year, the value of the coin triples. So that means the first year it was $2. So here's our years. That's x. And f of x, the function of x, is the value. So here I'm asking you to actually show me the pattern here of the factors, that is the multiples, and then the exponent form. This is just 2. This would be tripling, so that would be 6. In other words, this is 2 times 3, or 2 times 3 to the first power. Then we triple it again, so 6 times 3 is 18. So this is 6 times 3. That's 2 times 3 times 3, like so. Okay, this is 18 times 3. This is no longer something I can quickly do in my head, so if I do 18 times 3, it's 54. So 54, again, is 2 times 3. That got us to 6, times 3 got us to 18, and times 3 got us to 54. Make sure that you're actually, this is actually equal to this, okay? So we can start to see the pattern now. This is 2 times 3 to the second power. This is 2 times 3 to the third power. So this is going to be times 3 times 3 times 3 times 3, 162, and this is 2 times 3 to the fourth power. So the function is going to be f of x equals 2 times 3 to the fourth power. How much is the coin worth after 16 years? Well, after 1 year it was worth 6, so after 16 we'll use our function 2 times 3 to the 16. 2 times 3 to the 16 is, holy moly, 86,093,442. 86,093,442. Wow, that's a good investment if in fact it triples every year. Excuse me. All right, next one, Miss Ayala's elephants. This year there are about 415,000 elephants in the world. Sadly, however, the number of elephants are decreasing an alarming 7% every year. So every year, that shows us that x is going to be representing years. And f of x, what the years affect is the number of elephants. Now, in this question, I am not requiring you to show me the factors, but if you do this, it will work to give you the function. So what I saw on the first quiz was that many of you did this perfectly. You got down to something like this. You didn't do this. You had trouble writing the function. So keep using the tools that you need, even if they're not required for you. So before there were any changes, or when we start at year 0, it's 415,000 elephants. The first year, there were 7% less. So remember that a 7% decrease at 7%, 7% decrease means 100% of what we had before minus 7%, or 93% of what we had before. So this is going to be 415,000 times 0.93, or 415,000 times 0.93 equals 385,950. The second year, it's going to be this times 0.93 again. So take this times 0.93 equals 358,933.5. Now, obviously, we can't have 0.5 elephants, so this is a model. And so if we were going to round this, I'm going to just clear this up so it's clear what I'm writing here. If I were going to round this, 0.5 rounds up, 34. So rounding is fine as long as you don't then use this value to calculate. You keep this in your calculator. So the third year is going to be this again times 0.3, or 0.93 times 0.93 equals 333,808. Now here, 0.155, that rounds down. So a reminder about rounding is that we would always round up if it's 0.5 or greater, or round down if it's 0.4 or lower, or even lower than 0.5, anything lower than 0.5. So 0.49 rounds down. Okay, so this is our sequence of elephants. We can see that the number of times I multiply by 0.93 is equal to the years, right? So this one, if let's say I did, what if it were 7? So 7 would be, right, I'd say 415,000 times 0.93 to the 7th. So I'm just giving you an example. You don't have to do this. I'm just saying, do you see how this is the number of times? So that means that the function is going to be f of x equals 415,000 times 0.93 to the x. However many years we are, that's how many times we multiply by 0.93. How many elements were there last year? Well, so we're looking at f of not 0 this year, but last year, -1. So that's 415,000 times 0.93 exponent 1 negative. 446,236.55. So this would round up, 237. Approximately how many elephants were there 12 years ago? Well, last year was -1, so 12 years ago is going to be f of -12. So we're going to put this in, 415,000 times 0.93 exponent 12, 991,408.6, so 409 is what it rounds up to. Over the first 4 days of March, LeBron James has the amount of trailing falls at the end of each day. So day. So we could say day 0. However, I'm going to notice that it's the first 4 days of March, and it says the end of March, which has 31 days in it. So it's going to be easier for me to think of, if I have the end of March, that would be day 31, right? So this would be day 1, this would be day 2, this would be day 3, this would be day 4. It's going to be easier for me to say, okay, well then 31 days later, 1, 2, 3, 4, get all the way down to 31, to use the same numbering system in my function and table as I do in the problem. If you start with day 0, then you're going to have to say, okay, the end of March, that means this is before any days have passed, so the March 1st is day 0, so March 31st is day 30. You're going to have to think about that a little bit further when you get down to this question. I prefer to number it as it's given. So this is 8, 20, 50, 125. You're given the numbers. Now, how do we write this function? Well, we're trying to say this is going to be 8 times what? And this is going to be 20 times what? It should be the same thing. We're trying to see what we multiplied by. So if I'm trying to say, okay, well, 8 times something gives me 20. Let's say I call that something b. Then I would divide both sides by 8 to get what b equals, right? So we're taking 20 and dividing it by 8. 20 dividing by 8. This is 2.5. 2.5. And then let's try this. 2.5 times 8 is 20, yes. And times 2.5 is 50. Times 2.5 is 125. Good. So the pattern is holding. So this is 8 times 2.5 times 2.5. This is 8 times 2.5 times 2.5 times 2.5. Okay, notice what's happening. 4, 3. My exponent is 1 less than the date. So my function is 8 times 2.5 to the x minus 1. This is 1 less than my x value. So here's my f of x, here's my x. That means that when I just say which has 31 days in it, just boom, I go 31, plug 31 in, f of 31. Right? I've done the heavy lifting of reconciling the exponents to the date. I just number it consistently. 8 times 2.5 to the 31st to the 31st minus 1. So this is 8 times 2.5 to the 31 minus 1, or to the 30, is big number, okay? So this is 6.938 or 94 times 10 to the 12th. So 6.9 billion followers is what this model would hold. So there's my answer. Turning over. Shasta received $1,200 for graduation, put it in an account that earned 6% per year. Jordan received $50 for his birthday. His mom told him that if he didn't spend it, she would give him double the amount each subsequent year. If they both leave their money alone until they graduate college 6 years, who will have earned more? So we're going to explain a reasoning, show our work. So first we're going to ask for the function. Shasta received $1,200 for graduation and put it in an account that earns 6% per year. So 6% increase, remember this means 100% of what we had before plus 6%, or 106%, and as a decimal, that would be 1.06. So Shasta is going to start with $1,200, and every additional year, we're going to multiply by 1.06. That means the first year, we're going to multiply once. The second year, we'd have multiplied it twice because we'd have 2 increases, and so on and so forth. This is Shasta's function. Jordan says he receives $50 for his birthday, and his mom told him if he didn't spend it, she would give him double the amount each subsequent year. So his mom is going to give him, his mom is going to double his amount. That's what this language is supposed to mean. I can understand if we say give him double, it sounds like, oh, on top of the $50. But I want us to practice, because this is kind of what's going to be on the test. We would say that his mom would double the amount. That would be the best way to practice this, because that's how we're going to word it on the test. Okay, so, oh, I have noises going on in the background, sorry. She would give him double the amount. So we would say that, or she would double the amount. So we would say that his common factor is 2. So Jordan, he gets, we'll call him, let's see, we'll say this is g of x, is he gets $50, and then every year that he doesn't spend it, we double that. So times 2 the first year, the second year would be times 2 times 2. So that means whatever the number of years is, that's the number of times we multiply by 2. So this is Jordan's function, 50 times 2 to the x. Now it says so it should be 6% per year. If they didn't spend their money, if they left alone until they graduate college 6 years, who will have earned more? So we need to find what f of 6 is and what g of 6 is. Now we leave you a whole bunch of workspace here, because it may be that you want to create yourself some tables and say, okay, I'm going to do 6% increase, 6% increase, 6% increase, and work it out that way. That's good. I encourage you, use the space you have and the tools you know to get to the answer, however that works best for you. This is how I'm doing it, because this is how it makes sense for me to start putting it in functions. 1,200 times 1.06 to the 6th power. F of x is 1702.22, so 22 cents. 2.22. And g of x, 50 times 2 to the 6th, 3,200. So Jordan will earn more. In fact, if I want to be really precise, will earn $1,497.78 more. In an answer like this, I encourage you always, again, to show your work. If you got one step wrong, I could say, oh, that's one step, but you did the rest of it right. If all you do is write me answers and there's something wrong with the answer, I can't give you any credit. So please remember, always show your work. All right, now we turn to graphs. Complete the blanks for the graphs function for the function graph below. What is the common factor ratio? So if we were to put this into a table, we'd have x is 0, f of x is 3, 1, 6, 2, 12. We can see that 3 doubled is 6, doubled is 12, so my common factor or common ratio is 2. The y-intercept is 3. And then it's asked for end behavior. So remember, when we say as x approaches infinity, x is the horizontal variable. So we're saying as we get further and further to the right, what is happening to my points? Right? Each of these points that are part of this curve are getting further and further away from 0 in the positive direction. So here we say f of x approaches infinity. It's getting closer and closer to the infinitely high. As x approaches negative infinity, as we get further and further to the left, what's happening? Well, as we get further and further to the left, we're getting lower and lower, but not steeper, but we're getting flatter. So that means we're getting closer and closer to a particular number. In this case, you can see that is this 0 line. So here's our f of x, right? A scale. And we're saying, look, it's getting closer and closer and closer to this 0. F of x is approaching 0. Graph and interpret the function. So this, we give you the graph, and then we give you the what it means to interpret, which is to tell us this and explain. If you need to use a table, use a table. So, in fact, I would say it's probably a pretty good idea to use a table because you're showing your work. So 0, if x is 0, that's going to be 6 times no 1/2. Right? We're going to have 0 multiples. This is going to be 6. Another way to put that is anything to the 0 power is 1. So that'd be 6 times 1. When x is 1, that means 6 times 1/2, that's 3. When x is 2, that would be half of 3, which is 1.5. When x is 3, you can see that we would keep doing it by half, so this would be 0.75. All right, I'm getting smaller and smaller and smaller, so there's a limit to how small I can get and meaningfully graph this. So I'm going to create a second table, and let's try some negative values. If x is -1, you can reason through this. You can say, well, look, if I'm going by a half this way, I'm going to double it going back the other way. But watch, you can also put it right into your calculator. 6 times 1/2, 0.5, to the exponent power of -1. 12. 6 times 0.5 to the -2, 24. Okay, that's probably good. I'm probably not going to graph 24. Now, how do we set up a graph? We practice this. I noticed that 1, 2, and 3 I'm already getting too small. -1, -2, -3 is going to be 48. That's probably going to be way too big. So on my x-axis, I could count every other one at least. Right? I could go 1, 2, and 3, and even then it would be probably way more room than I need. So I'm going to actually do every third one. 1, 2, 3, -1, -2, -3. Okay, every third one. 0, 6. So then I can decide, do I want to go all the way up to 24? Do I want to go only up to 12? As long as I'm consistent, it's not. It's fine. Let me count the grid lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to make a little mark here so I don't get lost. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. So you can see that I've got plenty of room, 30, 31, 32, 33, 34. So I've got 34 grid lines. 34 grid lines. If I get to, I'm not going to get to 48 by counting by ones. If I count by twos, or if I count by halves, right, then I'm going to get to, I'm not going to get to 24. So if I count by ones, that's going to be about right there, is 24, negative 224. I think if I count by every other ones, right, that would only get me to 17. So I'm going to say, I'm going to try and get this value in, okay? So this value in, if I divide 34 by 24, or excuse me, if I take 24 and divide it by 34, that means 0.7. I don't want to count by 0.7s. So I'm going to say, let's count by ones. Okay, a couple different ways of explaining that. Essentially what you're saying is, how can I divide these grid lines up and still get the function meaningfully graphed? And I'm going to say, you know, it really makes sense for me to count by ones, because anything else, it's either going to be too squished or I'm going to run out of room before I even get a chance to graph one of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 30. So negative 2, 24. So here's negative 2, 21, 2, 3, 4. Negative 1 is 12, 12, 0, 6, 1, 2, 3, 4, 5, 6. 1 is 1, 2, 3. 2 is 1.5. 3 is 0.75. And I've got myself a nice curve. Okay, one of the things I am checking on here is, are your points accurate? Is your scale sensible? Do you use the graph? Are you showing me an accurate graph? So don't scribble on this. Take your time and mark the points precisely. Now, is this considered growth or decay? Well, this is considered decay because as my x values increase, my f of x values, so this would be as my input increases, my f of x values get closer to 0. Okay? It is not enough to say they decrease. Right? A decreasing function could look like this. Okay? So this is not decay when it looks like this. So we have to say they get closer to 0. Okay? You could also write this as an end behavior. You could say, as x approaches infinity, f of x approaches 0. That would also be a good justification. As we get further to the right, it gets flatter. It gets less steep. Oh boy, I see my phone is screwing up, so we're going to cut this off.